Okay, we are going to get started talking about parametric equations today. This unit will cover parametric and polar equations, and these are just different ways to locate points in the two-dimensional plane, in the coordinate plane. You've grown up learning the Cartesian system, I believe named after Descartes. Cartesian lets you locate any point by determining how far left or right of center and how far up or down from center it is. So if I find this point in the Cartesian system, that's right 3, up 4. Polar and parametric are similar in that we're going to have we're going to locate points in that way. We're going to have graphs and we're going to have slopes and distances and speeds, but we're going to locate the points in a different way. And today we're going to start with parametric. Parametric basically isolates x and y and puts them both in terms of a separate variable t. Usually it's t. If you use trig, a lot of times it'll be theta. But I like t because it's kind of like the time variable. And it's not necessarily literally time. It's not that, you're measuring time ticking. But at a certain time, or at a certain t value, you can find the x and the y coordinates separately. So this one's similar to Cartesian because we're still locating points by how far left, right, up, or down we are, but you can find separately left to right and then up or down, and then there's some applications that go along with that. So let's start by just sketching a graph. Normally, you've graphed like this before. Give me an x, I'll plug in the y because y depended on what x was. Now we're going to have a third t because x and y both depend on what t is. For this particular graph, because I know what it's going to look like, I'm going to graph it from -4 to 2. So when you graph, you're still finding the point, but you're going to have to plug the t into both equations to get the x and y parts of the point. Okay, so when t is -4, x of t, x of -4 is -4 minus 1, which is -5. Y of -4 is -4 squared plus 2 times -4 plus 3. And I'm plugging in just the same way I always did, where I would take my x and plug it in and get the y, but now I'm plugging this t into both the x and the y equations. So let's see, that's 16 minus 8, which is 8, plus 3, which is 11. So -5, 11 is the first point on my graph. So 1, 2, 3, 4, 5, 11. There's the point associated with t equals -4. Now, to save me plugging in all these numbers, I'm going to pause, fill them in, and then be right back. All right, so now I've filled in all of the values that I got by plugging in t is -4 through 2 into the x and the y equation. Each one generated an xy point. My next point was -4, 6, which would be right here. My next point was -3, 3, -2, 2, -1, 3, 0, 6, and 1, 11. You can see it generated a parabola. Now, the one difference, maybe not the one difference, but a big difference in the graphing of this parabola versus a different parabola is I need to indicate the direction in which I was moving as t grew from smaller to larger. Basically, from your first point, just draw little arrowheads that show I'm moving that way. Because a different set of parametric equations might create the same parabola that moves the other way. And if this is time that we're talking about, we want to know what this particle or whatever we're tracking, which direction it's moving. So this one is moving from left to right across this parabola. So there's graphing the old-fashioned way. So before we get to some calculator stuff, let's talk about this. This is just a parabola that you've been learning about for years. So what about just the regular parabola? Can I express this parabola not in parametric form? Well, that's going to be called eliminating the parameter. Basically, get the t out of there and give me an xy Cartesian equation f of x equals whatever, or y equals whatever in terms of x that stands for this parabola. So I'm going to rewrite my two equations and then get rid of the t's. And when you want to eliminate a variable, usually that's going to be done through substitution. So if I want y in terms of x, I'm just going to substitute the x's out, the t's out, and put what t is equal to. So based on this equation over here, if x is t minus 1, then t equals x plus 1. All right? So y equals t squared, which is x plus 1 squared, plus 2 times x plus 1, plus 3. Now, I've eliminated the parameter, and this is that parabola. Usually I want to clean it up a little bit. That's not the best form of the parabola. So I'm going to square out this first binomial, get x squared plus 2x plus 1. I'm going to distribute the 2. I'm going to add 3. And when I put all those together, I get x squared plus 4x plus like 6. So this is the same equation. This is the same parabola. It just doesn't have a direction now that I've taken my t's out. X squared plus 4x plus 6 would look exactly like that graph. All right. So I talked about how these are different ways to find spots, parametric and polar. Polar is quite different. Parametric is just slightly different. All right. We just added in a third variable. Kind of think of it as time. All right. So let's go to the calculator. You've probably never done this before, but if you've got a mode on your calculator and you've got your calculator's probably on FUNC for function, there's parametric and polar and sequence. Change it to parametric. All right, and some interesting things happen to your calculator. First of all, when you go to y equals, it's now x1 of t and y1 of t. So it changed over to parametric mode. So it's asking us for two equations now that will generate one graph. If you go to the table, you'll see the table that I just made, the t value, the x and the y that correspond to that t value. If you go to the graph itself, you should see that parabola that we just drew. And it's close, but look, there's part missing. So what's going on with that? Here's the parabola we just drew. And my calculator is only showing me this much of it. So here's where your calculator is interesting if you go to put it in parametric mode. If you go to window, look at my t. My t minimum is 0 and my maximum is 10. All right? So it's going to only graph based on certain t's being plugged in. So I get the section of the parabola that goes from 0 to 10. Which is why I only have a little bit of it. So you might have to go adjust your t's. If I go minus 10 to 10, that should be enough. And that t step 0.13, that's probably like pi over 12 or something like that, some sort of pi. But that shouldn't matter. You can make it 0.1 if it bothers you. But I just needed enough t's to be graphed. So your calculator is going to plug in t's and generate those points. And if you aren't plugging in the right t's, you might not get the full picture. All right, so I only plugged in minus 4 to 2, so technically I only have this bottom section of the parabola. Your calculator can be a little misleading if you aren't careful with that. So remember what this graph looks like. To confirm our other answer, if I go back to mode, it's cool when you're in parametric and you hit the xt theta n button, it produces t's now instead of x's. But if you change your mode back to function, go back to y equals. Now you've got just normal y's like you always have. And let's go find that equation we just found. That was x squared plus 4x plus 6. X squared plus 4x. My button produces x's now. Plus 6. If we go to the picture, we get the exact same picture. It's just now it's y in terms of x instead of x and y both in terms of t. So that's just our kind of intro. This is basic parametrics. We're looking at x's and y's separately. And that's that. Now, we're going to do some work from our book, and it'll look sort of like that. I'll ask you to eliminate some parameters and stuff like that. The most concerning thing is what is going to happen on your AP test. Now, I showed some of you this question in class. Our next section is going to be on the calculus. We haven't really done calculus, right? All we've done is it's given one equation and broken it into two parts. The calculus is coming up soon. That's when we're going to learn how to find distance. That's an arc length question. Tangent line. That's all calculus. Tangent. And part D is going to need some calculus too. But part A is a very common question. What's given to us is two parts. Not here's a particle and it goes along this equation, y in terms of x. We have its x position in terms of t. We were not given its y position in terms of t, but we were given dy dt. All right, so you've got position, acceleration, velocity, or position, velocity, acceleration. Those work in two parts, just like x and y both are in terms of t. You can have x prime of t, y prime of t. The thing we can answer without any calculus is speed. Speed, and some of you have done this in physics, and some of you have done this in geometry. This is just a vector question. We've got an x velocity and a y velocity. It's moving side to side and it's moving up and down. So what we need is the x velocity at 3 and the y velocity at 3. And we're going to basically make a little triangle out of those and do the Pythagorean Theorem. So what we need is x prime of 3. This is the x velocity at 3. Square that. Take the y velocity at 3, and we would get that by plugging 3 into this value. For x prime, we would have to actually find x prime of t, get 2t minus 4, and substitute 3 into that. But we square them both and square root it, right? X velocity would be like this. Y velocity would be like this. I'm not sure if they're both positive, but the speed is here. It's just an application of the Pythagorean Theorem. All right, so x prime of 3, y prime of 3, square them both, add them, and square root. For the sake of time, I'm going to jump down there to the answers, 2.82. All right, but that one we had to find x prime. We were given y prime, but the thing I want you to notice is the speed. All right, they will ask you that definitely on your test to find a speed given some parametric equations. They don't use the word parametric usually on the AP exam, but that's what it is. So we'll be taking some time to look through old stuff and figure out how to apply this new stuff to the AP exam. All right, it's the same content, just maybe with some different terminology. All right, so that's going to do it for our intro to parametrics. I'm pumped about the Spirograph project. You're going to get that soon. Young out.